Hello everyone. In this lecture we're going to be making an introduction to time value of money. And before we do that, I want to make sure that we're all clear on time value of money being the single most important topic in the field of finance. Why? Because the majority of the topics we cover in the field of finance, one way or the other, is related to time value of money. As you will see with the topics that we cover going forward, almost everything, including stocks, bonds, project evaluations, and any other sort of evaluation that is done across time, involves time value of money. Once you understand the logic of time value of money at its core, you realize that everything else that we cover is basically the exact same thing over and over again. Now, terminology might change, but the calculations don't. When we get into especially stocks and bonds, hopefully that will be more clear to you. But just for now, please understand that time value of money is extremely important in the field of finance. So the logic starts with consume now or consume later. We talked about this before, right? Whenever you choose not to consume now and you choose to consume later, you basically give the money up for a period of time. There's someone on the other side that's needing this money, so they ask for it. And over time, you wait until you get your money back, and you get your money back with some sort of a compensation for the time that this money was away from you. Now, there are two reasons that you get this compensation. Number one, time is costly. What I mean by time being costly is the logic of opportunity cost of capital. What is opportunity cost? If you've taken any sort of an economics class, I'm sure this topic was brought up before. Opportunity cost is the foregone benefits of the alternative. In other words, if you have two options in front of you, A or B, if you pick A, then basically you give up everything that you could have gotten from the option B, and that's your opportunity cost. Opportunity cost can be in terms of many things, including cash, but it can also be utility or satisfaction. I could use the money up right now and buy what I've been wanting to buy for a long time, or splurge on this with this money on whatever I would like to enjoy at the moment. That gives me a level of utility or a level of satisfaction, and I'm giving that up by choosing to consume later. So there's a cost associated with that. But more importantly, as we mentioned before, time is risky. If I tell you, would you like the money that I owe you tomorrow or 10 years from now, of course you will say tomorrow. If I ask you why, the most simple answer is, well, I have no idea what will happen in the next 10 years, to you or to me. So time is risky. As time increases, the amount of risk one faces increases as well. So what happens is you get compensated for that time. It's important for you to understand that you get compensated for time. You don't get compensated for anything else. When I say money's value across time, I mean $1 million 10 years from now is not worth $1 million today. Because $1 million 10 years from now is, there can be many things, right? Some of you will think, well, there's inflation. Some of you will think, well, cost of living will be significantly different. Some of you will be saying, well, if I have that $1 million right now, I could do so many things with it. I have no idea if I will be even alive to spend that $1 million 10 years from now, so on and so forth. So money, when it moves across time, becomes less valuable unless you get compensated for it. And that's why we get compensated for time. Let's look at a very simple example. Again, I'm not insulting your intelligence with examples like these, but turns out the entire core of time value of money bases itself on examples as simple as these. So we start with $100. At the beginning of the year, you have $100. You're going to make 10% interest on this for the next year. How much will you have at the end of the year? Well, you'll have $110. But more importantly than that, understanding that $100 in present value is $110 in future value. In other words, $100 now is worth $110 in the future at 10% interest, or $110 in the future is only worth $100 today. That last statement is very important. $110 1 year from now is only worth $100 today. If we take the cost of time, which is 10%, into consideration. What I'm about to tell you is extremely important, so please listen carefully. If there was no cost associated with time, then present value and future value would be the exact same thing. The only difference between present value and future value is the cost of time. So in other words, $100 today is the same thing as $110 1 year from now if the cost of money is 10%. So the most natural topic after an introduction to time value of money is understanding how interests work, or how returns work, or how yields work. Doesn't matter, again, what it's called. I mentioned this before. Guys, no matter what these guys are called, it's all the same thing. Interest rate, required rate of return, internal rate of return, yield, whatever it's called, it doesn't matter. They're all interest rates. At the end of the day, again, you only have one button for them on your calculator. So don't let those confuse you. So simple versus compound interest. There are two types of interest. Turns out, it's said that compound interest is the biggest invention in the field of finance. Why? Well, if you compare it with the idea of simple interest, an investor that engages in compound interest receives exponentially higher returns in the long run compared to a person who's receiving only simple interest. So what do we mean by these? Simple interest is nothing more than you receiving the exact same percentage of the original money period after period. So if you have $100 and you're earning 10% simple interest, you're going to get $10 for this year, and next year you'll get another $10. So at the end of 2 years, you'll end up with $120. Compound interest, however, is the idea of making interest off of previous period interest as well. Or in other words, the interest applies to the account balance at the beginning of the period. So if you start with $100, first year at 10% interest, you'll be making $10. At the end of the first year, your account balance is not $100 anymore, it's $110. So the second period, interest of 10% will be applied to not $100, but $110. So in effect, at the end of 2 years, instead of ending up with $120 like it is in simple interest, you're going to end up with $121. So that's the idea of compound interest. Now, this might sound like, well, it's not that big of a deal, it's just $1. But if you actually do this across time, a long periods of time, you realize that compound interest is hands down going to be a huge difference in terms of your returns. So let's look at a very basic example. Simple interest, you invest $1,000, 10% interest rate, but simple interest rate. How much will you have at the end of 2 years? Well, you start with $1,000. First year, you're going to make $100 in interest, so you will end up with $1,100 at the end of first year. For the second year, you'll be making 10% of $1,000 again, which is another $100. So you will end up with $1,200 at the end of year 2. However, if you look at the exact same problem with compound interest, You start with $1,000. At the end of year one, your account will have $1,100. So whenever you receive 10% for the second year, you're going to be receiving 10% off of $1,100. So your account balance at the end of 2 years will be $1,210. So you made this extra $10 through compound interest in this example. So in time value of money, I need to make sure that everybody is clear on the terminology. We have 5 terms that we deal with through any sort of time value of money problem. The first one is PMT, or payment. What it refers to is to cash payment each N period. And N is defined below, and you'll see that in a little bit. PV represents present value. FV represents future value. N represents number of periods. So this can be number of years, number of weeks, number of months. It's a number of periods, regardless of what it's called. It's how many times something is repeating. That's what N is. I over Y is interest rate applying to each N period. In other words, if N is 1 year, then interest rate is the interest rate for that year. If N is 12 months, then interest rate is for each month. Remember I said PMT, cash payment, is for each N period. What that means is if I have N of 12, and that's 12 months, then that means the payment will be 12 times. So you will be receiving a payment every single month. Now, you will realize, if you've not done already, all these little terminologies are reflected on your financial calculator. Now, I use BA2 Plus with Texas Instruments as my financial calculator of choice. And everything that I mention in this lecture will be through the BA2 Plus. Although most all financial calculators are very similar to each other, there can be some slight differences. So I urge you to look at the manual of your own financial calculator and follow through that. But I'll be using the BA2 Plus with this lecture. If you look at the financial calculator, you'll realize that all of these notations, or these categories we just mentioned, PMT, PV, FV, so on and so forth, are mentioned on your financial calculator. In fact, if you look at your financial calculator, the third row from the top is grayed out, and all those are exactly the notations that we just mentioned. Turns out, with almost every sort of financial or time value of money type problem, as long as we know where each number goes into, or which bucket or which category each number goes into, calculating time value of money problems are extremely straightforward. So before we get into the financial calculator though, I think it's valuable to understand the basic mathematics of time value of money. Now, I get this a lot. People say, well, I don't want to learn formulas, and I don't need formulas. I have the calculator right in front of me, and as long as I know how to use the calculator, I'm not required to use the formulas. Who in the real life actually uses formulas? I agree. I promise you, I agree with that. Yes, I had to learn every single time value of money in formula sense, and the most advanced ones for that matter, when I was doing my graduate work. But I realized that that's actually not necessarily a well-utilized time for a student. However, at least the basic logic of time value of money is important before we move on to the calculator logic. And I promise you, this is not really a formula. You can look at it as a basic sentence. And as long as we understand this going forward, the calculator will make more sense. We say that future value is present value multiplied by 1 plus I. What does that mean? Well, in an extremely basic sense, or the example that we gave in a previous slide, we said if you start with $100, you make 10%, you will end up with $110. And we said present value is $100, future value is $110, right? That was the example that we said. So turns out we can do that in this notation. $110 equals $100 multiplied by 1 plus the interest rate. Sometimes I get this question asking, why do we have a 1 there? Well, the reason you have a 1 is because 1 gives you an anchor point. In other words, future value is present value on top of 10% of present value. In other words, if I just said future value is present value multiplied by interest rate, and 10% is the interest rate, and my starting point is $100, or the present value is $100, your future value will end up being just $10. But we know that's not the case. It's not $10, it's $110. In other words, we have the present value, which is $100, and then we add $10 on top of it. That 1 is for that. And in other words, that 1 represents the present value. Interest rate represents the percentage of the present value that we're going to add on top of the present value to get the future value. So each period will be earning whatever we stopped from, or we're going to be earning a percentage of the previous balance, right? So at the end of first year, we'll end up with $110. Next year, it's going to be $110 multiplied by 1 plus I. And then the third year, it's going to be $121 multiplied by 1 plus I. Turns out that 1 plus I is what we calculate for each period. So for 3 periods, future value would be present value multiplied by 1 plus I, and then multiplied by 1 plus I again, and then multiplied by 1 plus I again. In other words, we could rewrite this as future value equaling present value multiplied by 1 plus I to the power of n. For 3 periods, that n would be 3, right? So this exact same logic can be reversed to find present value. It's a very simple algebraic function. If future value equals present value multiplied by 1 plus I, then present value must be future value divided by 1 plus I. So from a terminology perspective, it's extremely important for everyone to understand that when we're going from present value to the future value, we're compounding. But whenever we're coming from future value to today's value, we're discounting. That makes sense, right? $1 million 10 years from now is worth less than $1 million today. So I need to discount $1 million 10 years from now to find what it's worth today. So that's where the logic of discounting or discount rate comes from. So let's look at an extremely simple calculation, and this time let's use our calculator. You want to deposit money into a savings account. How much will $1,000 be 10 years from now at 7% interest per year? And when I say 7% interest per year, unless I specifically tell you it's simple interest, then you automatically assume that it is compound interest. So before we do this calculation, let's go to our calculator. It's extremely important that before you do any sort of a calculation, you clear your calculator's memory. Your calculator remembers the previous calculations you did, and if you don't clear your memory, then the new numbers you enter in will be jumbled up with the previous problem, and the answer you get will be incorrect. So it's extremely important for you to understand that you have to clear your calculator's memory before you start. I have had this question before where someone said, why did they make it like that? That's just an inconvenience for me. Well, the reality is, it's a good thing that your calculator remembers what's been doing in the last few button strokes. Because you can do side calculations on your calculator, as I will demonstrate in a little bit, while you're doing the full time value of money calculations. And because the calculator doesn't forget what you've done so far, you can continue with where you stopped. So, how do we clear the calculator's memory? There is a button called Second, and it's on the BA2 Plus. It's a different colored button. It's the from the top left side. It's the second row. You'll see that button, Second. Second is the same thing as on your computer, the Shift button. So once you press Second, you go and press the FV button, or the future value button, because on top of future value it says CLR-TVM. In other words, clear time value of money. So if I press Second and then clear time value of money, it will clear the memory of the calculator. Again, it's Second, FV. That's what you do to clear the memory of the calculator. So let's do that. Second, FV. Now we have the calculator clean. Before you do any sort of a time value of money problem, during the exam or otherwise, I urge you to do this little chart that I'm showing here before you even attempt to solve the problem. I even personally myself, having done extensive and a lot of times extremely boring studies in finance, realize that I can make mistakes to this day if I don't come up with this little chart myself before I solve the problems. So I urge you, please, don't rush into the calculation. Do this chart first, because once you figure out the chart, calculation is as simple as entering those values in the calculator. That's it. So the chart consists every single time of 5 different variables. It is important for you to understand that each variable doesn't have to be a value. It can be 0. However, you can only have one unknown. You cannot have 2 unknowns in time value of money calculations. You can have zeros, but you cannot have 2 unknowns. So the first thing that you should be doing is figuring out which one is the unknown. In this particular example, future value is the unknown one. So, because that's what the question is asking. So let's put the question mark under future value. PV stands for present value, right? So we will start with $1,000 in present value. As you might see, I put a negative sign in front of the 1,000. The reason for this is simple. You cannot get something for nothing. So if you are investing $1,000, that's money coming out of your pocket. So it's a negative. Any money you will receive in the future will be a positive to your pocket. So you give up 1,000 today in present value terms, and once you calculate future value, you'll see that it's actually a positive number. So you can't get something for nothing. I get this question a lot, saying which is which. I'm confused. Should this one be negative? Should this one be positive? Doesn't matter. As long as the way the money moves in and out of pocket is referenced somehow in the negatives, you're good to go. In other words, yes, you're putting this money into a savings account, right? So it's a negative to your pocket, and the future value will be a positive number to your pocket. However, if you look at it from the banker's side, present value will be a positive to their pocket, and future value will be a negative to their pocket. So as long as you have the negatives and positives, it's okay which one, it's okay, or it doesn't matter which one is which, or which side of the table you're sitting on. So let's make sure that we enter these numbers correctly. We said future value is the question mark, and we also said that present value is negative 1,000. N refers to a number of periods. In this case, we're talking about years, and so we have 10 years, so N is 10. interest rate is 7%, it's important for you to understand that your calculator understands that I over Y is a percentage, so you do not have to convert 7 into a percentage number. As long as you put 7 under the interest category in your calculator, the calculator knows that it's a percentage. Payment refers to any repetitive cash payments in the number of periods. Are we receiving any cash between the depositing of the $1,000 versus 10 years from now receiving the money? No, there's nothing happening in between. So payment is 0. Let's put this in our calculator. So the logic to the calculator is you first enter the value and then define what that value is. So first we put 1,000 in the calculator, but because it's a negative, you press the positive negative sign. Don't forget, this is not the minus sign. This is the positive negative sign. And where is that located? At the very bottom of your calculator. At the very bottom of your calculator, towards the right, you see that positive negative sign. So if you push that, your 1,000 on the screen will become negative 1,000. Now we know that this is the present value, so we need to define this negative $1,000 as present value. All we have to do is push the PV button, and now the screen will show PV equals negative 1,000. After entering everything, you have to push the enter button. So enter button is at the very top of the calculator, second from the left. Sometimes people that have some experience with financial calculators will say, well, Al, with this one you don't have to push enter because the calculator already knows. Although that is correct for this type of calculation, there are many other time-valid calculations that requires to push enter button every single time. So my advice to my students is, instead of trying to remember what to do in different situations, just do the exact same thing every single time and you will never make a mistake. So after entering everything, press the button enter. So now the next one in our list is future value, but there's a question mark besides it. So what we do is leave the one with the question mark to the end, because there can only be one unknown and the calculator cannot calculate the one in question without knowing everything else. So we move on to n being 10. So what we do is we push 10, or we type 10 in our calculator, and then press the n button and then push enter. Next one is I over Y equaling 7. So I first press the 7 and then push the I over Y button and then press enter. PMT is 0, so I push 0, then press PMT and then enter. Do not think that because something is 0, you don't have to enter it. In a lot of calculations, the calculator will require you to put in the 0 value in there. So just make it a habit of every time pushing the 0 or entering the 0 value into the calculations as well. And so we entered everything in there. Now we need to see what the future value is. How do we calculate future value? All you have to do after entering all the information is push the compute button, and compute button is the CPT button. It's the the very top left-hand side. The letters C as in Charlie, P as in Peter, T as in taxi. That's the CPT button. You push that button, and then press future value. So in other words, while you're entering the data, you always put the value first and then define what that value is. But when it comes to calculating the unknown, you first push the compute button and then press what you wanted to compute. And if you pushed all the buttons correctly, the answer you should find is $1,967.15. Now, a lot of times people borrow calculators from other people, and the settings of those calculators are different for different people. And if the setting or the initial setting of the calculator is different, then your calculations will be based on those settings, which are not true for what we are doing. So my advice to you is to check for a few things. The first thing that you should check for is the periods per year. Press the second button and then push the I over Y button. The screen should show P over Y equals 1. Push the down arrow and then you should see C over Y equaling 1. If these are not the case, then correct them to 1. Another thing is that you need to always set your calculator to 4 decimal points. How do you put your calculator to 4 decimal points? Press the second button and then push the period button at the very bottom. Once you press that, it will say something like DEC equals 2 or 4 or whatever. Always put that into 4 decimal points. So just press 4 and then push enter. Now DEC will say 4.0000. So you're good to go. Now you can just clear your calculator by pressing CEC and you're good to go. Alright, so let's move on to other types of time value of money calculations. The type of time value of money calculation that we see very often is an annuity. Annuity refers to any standardized payment that is repeated over time. So with an annuity, you don't get $100 one period and $500 another period. You get the same amount every single time. There are two types of annuities, ordinary annuity versus annuity due. Ordinary annuity assumes that the cash exchange is done at the end of the period. Annuity due assumes that the cash exchange is done at the beginning of the period. For our purposes, we will always assume that exchanges are done at the end of the period. So for our purposes, we will be calculating ordinary annuities for now. Unless I specifically tell you annuity due, you always assume that everything is ordinary annuity, and so therefore the cash exchange is done at the end of each period. There's an example here. It says, what is the present value of $1,000 ordinary annuity for 5 years? So in other words, if you're going to be receiving $1,000 every year for the next 5 years, how much is that worth today? Another way of looking at it is, if you, given the interest rate, if you wanted to be indifferent between receiving an amount of money today versus receiving $1,000 every year for the next 5 years, what number would that be? Or what present value to you would make you indifferent between receiving $1,000 every year for the next 5 years versus receiving that lump sum amount now? Well, if you wanted to calculate this by hand as is shown on the slide, it's very simple. All you have to do is just discount each of the $1,000, depending on what period it's at, to today's value, and then add them all up, and that will give you the present value of this annuity. However, there's a simple way. The calculator provides a much easier way of calculating this. Again, let's go back to our calculator. Let's clear our calculator's memory, second FV. And before we start the calculator, let's make sure we put up our chart and enter everything into the chart like we did on the slide. Present value is the one we're looking for. PMT is $1,000 because it's an annuity and it repeats, right? And the definition of PMT is an amount that repeats n times. So $1,000 we will be receiving and as you can see, the $1,000 here is positive because we're going to be receiving that. That's going to be coming in our pocket. FV is 0. I get this question a lot. Well, why is FV 0? I will be receiving $1,000, in the 5th year too. So isn't that a part of? Isn't that a future value? Here's the definition of future value and the difference between future value and payment. Future value is a one-time lump sum amount that gets exchanged. One time. Anything that repeats is not future value. Anything that repeats is payment. So in this calculation, are we receiving or giving up a lump sum amount or a one-time lump sum amount at the end of 5 years? No. So future value is 0. Interest rate, according to this problem, is 6%, so we just put in 6. N, or the number of periods, is 5, or 5 years in this case. If we go to the calculator and say, and start with the numbers because we can't start with the unknown, we have to leave the unknown to the end. We say $1,000, so we put in $1,000 and then press the payment button and then enter. Then we put in 0 and then the FV button and then press enter. Then we put in 6 and then interest rate button and then enter. Then we put in 5 and then N button and then enter. And then we press the compute button or CPT and then push PV or present value button. If you've done this correctly, the answer should be $4,212.36. Oh, by the way, although I told you that the calculator should be set at 4 decimal points, the answers will be always given to you in 2 decimal points. The reason we're setting it at 4 decimal points is for precision purposes. But the answers you will see will always be at 2 decimal points. So it will be up to you to convert the 4 decimal points to 2 decimal points. Alright, so let's look at some other types of time value of money problems. And here's another common problem and something that a lot of retirees are worried about. If you will retire with $1 million cash in your account and planning on using $100,000 a year, how many years would this money last if the bank's interest rate is 6%? Why is this so important? Well, you don't want to run out of money too soon, right? So you want to know how long this money will last given an interest rate that's paid to you through the bank. So let's create our little box. In this case, you have a present value of $1 million. That's already in your pocket, so we just say that to be positive. You're going to be spending $100,000 out of your pocket every year. So that's a repeating number. And because it's a repeating number, that goes into the payments category. And because $100,000 is going out of your pocket, we mentioned that, or we put in that as a negative, or a deficit to your number, or a decreasing number. The next one is future value. We put future value to be 0 because we're trying to calculate how many years would this money last. And when at the end, we're not supposed to have any money left. So future value is 0. We're not going to be exchanging a lump sum, one-time lump sum of money at the end. Interest rate is 6. And N is the question mark, because we're trying to see how many repeating periods will we spend this $100,000 before future value becomes 0, or we'll run out of money. The answer is 15.7 periods. In our case, that's years. So this money will last 15.7, so approximately 16 years. If you spend $100,000 a year out of the $1 million you have, if the interest rate in the bank is 6%. Here's a very common type of change to a time value of money problem. So far, we've been saying that everything is compounded yearly. Now, every interest rate, by definition, is quoted yearly. It doesn't matter if the compounding is monthly, payments are monthly, daily, quarterly. It doesn't matter what the case is. They will always be quoted to you yearly. But if something gets compounded more than once in a year, in essence, you make more money than if it was not compounded. Why compounding more than one time a year is beneficial to the investor? Because you get the opportunity to earn interest off of the previous interest more often given a year. Let's look at a very simple example. How much will $1,000 be in 1 year if interest rate is 10% compounded yearly? Well, of course you know that it's $1,100, but let's look at it from a calculator's perspective. Present value is 1,000, and in fact that should be negative 1,000. Future value is the question mark. Interest rate is 10%, payment is 0, n is 1. The answer will be $1,100. Of course you anticipated that. But what will be the ending result if compounding was happening semi-annually? In other words, although from a year perspective you're earning 10% interest rate, you're going to be compounding this every 6 months. In other words, at the end of the first 6 months, you'll receive 5% interest, because half of 10% is 5%. You'll receive 5% interest at the end of first 6 months. And then the second 6 months will start from the balance as of at the end of first 6 months. So you'll earn interest off of the first 6 months as well. Let's plug that into the calculator. Present value should be negative 1,000. Future value is the question mark. Interest rate is 5. PMT is 0. N is 2. Interest rate is 5. N is 2. Remember, interest rate is the rate that applies to each period. Although I have 1 year, I have 2 periods. I have the first 6 months, and then I have the second 6 months. And interest rate that applies to each 6 months is 5%. And that's why interest rate is 5 and N is 2. If you run this, the answer will be $1,102.50. So as you can see, it's a larger amount than if this was compounded only once a year. So the more compounding, the higher the value of money. So let's look at a very common problem for a real life scenario. All of us have or will buy a car at some point, and if you go to a car dealership, this is the type of scenario you typically face. You buy a car for $20,000, and interest rate you're being charged is 12%. Well, if you ask me, run away like crazy if they're asking you 12%. But let's say that you're okay with 12%. So that's 12% yearly. Don't forget, interest rates are always quoted yearly. But with monthly payments for 5 years, how much will each payment be? All right, so the idea here is, although interest rate is quoted yearly, payments will be monthly, so N will be in terms of monthly, and therefore interest rate that applies to each N should be monthly. Everything has to be apples to apples. So present value is $20,000. You can see here that it's a positive $20,000 because whenever you receive the value, that's like it's coming in your pocket. The payments you make towards this loan will be coming out of your pocket, and the answer, as you can see, is a negative. But let's just start from the beginning. Present value is $20,000. It's a positive. Future value is 0 because at the end of the 5 years, you want to be done with your payments. You don't want what we call to be a balloon payment. You do not want a balloon payment. All you want to do is pay off this loan in 5 years and be done with it. Interest rate is not 12%, it's 12 divided by 12. Why? Because payments are monthly, so the interest rate needs to be converted to monthly. So therefore, for each period, or in this case for each month, the interest rate that's applied is 1%. So I over y, in fact, is 1. N is not 5, although it says 5 years, but each payment will be monthly. So we have 60 payments, or 60 periods. And the question is, what is the payment? If you enter all of the numbers correctly, you'll see that the payment will be a negative $444.89. In other words, if you pay $444.89 a month for the next 5 years, you will pay off this $20,000 car that you bought. I'm sure if you do a very simple calculation and multiply $444.89 by 60, because you're going to be making 60 payments of that, you'll see that that number is a lot higher than $20,000. In fact, the interest rate is going to be killing you in this case. So, this concludes, at least for this particular lecture, this concludes the idea of time value of money, or concludes the introduction to time value of money. In the next lecture, we're going to be talking about net present value, IRR, and uneven cash flows. Thank you.